So just keep that in mind. And the other thing too is that when you read a question, if it says acceleration or the object changes speed, right, you have to use one of these 5 equations over here. Like it's one of them. If the object is in uniform motion or going at a constant speed, then you use this equation over here. And I say that because there are times that I've seen students who should be using this equation but use this one instead. Because they look the same, right? They have the same kind of the same variables in them, but it messes students up sometimes. So just be aware, if it's uniform motion, so constant speed, constant direction, you got one option. That's it. If it's changing speed, you have 5 options, and then it's just a matter of what 3 variables are you given and which one do you need. Okay? Any questions with those guys? They are our focus today. So here are some questions. So I'm going to let you read it, talk to your little partner. I'll give you 30 seconds to think it out. Then I'll ask you what the answer could be, or what you think the answer is. These are all test questions from the past couple of years. And give me an example either way.
Yes, they can. You said it.
It's not also like a ball.
Can an object have a velocity equal to 0 but still have an acceleration? Oh.
Yes.
Okay, so we have yes. How many people are on the camp yes? All right, how many people are in camp no? All right, see, I love these questions. So some of you are right, some of you are wrong. All right, so team yes. What is your argument, for example, Andre?
So when we thought it was velocity's equation is v equals displacement over time.
Mm-hmm.
So if displacement is 0, you still have the possibility of like moving around. So therefore you can have acceleration. So that's what I can.
Okay, what would be an example of that though?
All right, let's say you had a distance traveled of 50, but
tell me something real life,
okay.
not just like put numbers in equations.
If you go around the track once,
Yes.
you have a distance traveled of 400 meters,
Yep.
but a displacement of 0.
Yep.
So you could have an acceleration by speeding up, slowing down around the track while you're going around it.
Yep.
But once you get around, your velocity is 0, but you can still have your accelerations.
Yep. Good. I like that. That's a good example. Team not true. Do you guys have an example that proves your point? Or did your mind just get switched? I know there's only 4 of you, so I can pick on all of you, but you guys have one? So the answer up there is true. It can have a velocity equal to 0, but have an acceleration. So Andre used a good example of going around track. Is there another example that you can think of that would be not track-based, but still have a velocity equal to 0 and have an acceleration? Alan?
If the statement was incorrect, most of the, or at least equation number 2 that we've written down wouldn't work, because if you have an instantaneous velocity of 0, your VI is 0, and it could not accelerate when it was at 0, then you'd have no acceleration. Does that make sense?
Acceleration.
That's true.
So if something can't
So
accelerate,
yeah, so
from
it
0,
should. So a better question than an average velocity equal to 0. So if it's not moving, you're right. It can not be accelerating. So that's true. So like you right now have a velocity equal to 0, but but the question is, but still have an acceleration. So yours would not hold true. The second one, another example I see quite often, is in projectile motion. If you remember in projectile motion, if you throw something up in the air vertically, the very top of its flight, it momentarily comes to rest. The instantaneous velocity is 0, and then it starts to fall again. But at that moment, gravity is still acting on your object. It never goes away. So even though it's momentarily at rest, your acceleration is still 9.8 meters per second squared down. All right, that's just another example. Okay. Number 2 here. Oh, move my mouse back over. Can the average velocity and average speed ever be the same? We already answered this one today. What's the answer to this one? So is the average, Brennan?
Assuming it's uniform motion, then yes.
Yeah, it has to be uniform motion, so a straight line, then they would be the same. As soon as there's a curve, then they won't be the same. Can the displacement ever be greater than the distance traveled? Take 30 seconds, think about it, talk it out. We'll have another vote. All right, survey says, is this true? Can the displacement ever be greater than distance traveled? Anybody in team yes this time? Ooh, everybody's team no. Why is it no? What's your argument for it? Brennan?
Because displacement is measured from a specific reference point or a starting point, and then distance is just the overall distance traveled. So the displacement will always be equal to or less than the distance.
Yep. Your distance, remember, is the path that you take to get there. If they're in the same, again, uniform motion, straight line, they would be the same. But as soon as you start to curve away or make a turn, right, the hypotenuse of a triangle is always less than the sum of the other two sides. Right, so the displacement will always be less than the distance traveled. Oh, can you have an eastward velocity and a westward acceleration?
Yeah.
Discuss. What do you think?
Accelerating on the other way. Its velocity is still going this way, but it's accelerating that way.
It's traveling on the and flip the car like this, and then accelerate this way, and you still have the momentum carrying it backwards until.
Well, no, because your acceleration from your initial.
All right, time's up. Somebody who hasn't answered a question yet today. Anybody want to volunteer before I pick on you? You already answered questions today. Any takers? Take a risk. Jackson, what do you think back there?
I think you can.
What's your object doing if you can?
So if it's a car,
Yep.
it can be driving eastward, but
Yep.
also braking at the same time, so you're accelerating westward, like the negative acceleration.
Yeah, perfect. Right, so that would be the explanation for anything slowing down. Right, your velocity is one way, but your acceleration is the opposite. And we did this one already. Kind of. What's the answer to this question? So a car can have an average speed, but an average velocity equal to 0. What happens there? Under?
We have a distance traveled, but not a displacement.
That's right. So what would the car be doing?
Making a round trip.
Making a round trip. Exactly. In theory, you are this, right? You will have an average speed today, but your average velocity could be 0 today, right? Because you are leaving your home, you come to school, you do what you do during the day, but at the end of the day, you return to the same home. So your displacement will be 0. So your average velocity will be 0 for everything you do today, but you would have an average speed. All right, so now we get into the fun stuff, math. So here we go. As I said on Friday, I do have all the examples online, and I expect you to access them with your phone at this moment when we take them up, because I don't want to spend 10 minutes of class of you copying it down. So they are there. I did change a few last night because I realized that some of the questions are from your textbook you're using now, so I can switch them. So if you look at this, right, we have Annabella leaves her house, walks eastward towards school. When she's 1.2K from her house, she realizes her cell phone has fallen out of her pocket. She retraces her steps to find her phone in the long grass after walking only 400 meters. The whole motion took 15 minutes. What's the average speed for the situation? What's the average velocity? And then there's part C, which is just an understanding type question. So I always find this a good question to start off with because it's going to accomplish a couple things. I'm going to show you my expectations for each question we come across going forward for the rest of the year because they are a little bit more in depth than our light questions. They're all for our next 2 units. At least maybe 3, they're all story based like this. So you have to take what you read and put it into a problem and find an answer. So there you go. Yeah, Andre?
So the 15 minutes is after she found her phone, 400 meters or back.
Yeah, from when she left her house till she found her phone.
All right.
Yep. Okay, so here we go. If you read this question, the first thing I'd like you to do, or what do you think the first thing is that you should do? Let's go with not what I know, but what do you know?
Write down your variables.
Sure, so let's write down our variables. What variable are we going to use for this question? There's lots of different options actually.
We have delta t, which is 50 minutes.
All right, so we have delta t, 50 minutes. That's not our standard unit though, right? So, or 15, not 50. What's that in our standard unit? Then like 900?
900 seconds.
Yeah. So make sure in your table of values that all your unit conversions are done right away. Right, always put them in the standard unit. What other variables are we going to put in here? So we can do a couple different things. What did you choose to do? That's not Alex. He's going to answer all my questions. Hunter?
Convert kilometers to meters.
Okay. Now what variable are we going to use for that?
What variable? D.
D?
Yeah.
But we have 2 of them.
D1.
All right. Are we good so far? Here's another tip. Is when you do your table of values, your directions should always be the same. So you notice in my table of values, they are not the same. I have an east and I have a west. So that's not, in my eyes, I would never do that. But you can, because you're different than me. How come I change it so they both say east? Because that's what I prefer. Well,
You could change D2 to be negative 400 meters east.
okay, why did you choose that for D2?
Just because it's a smaller number, so then your distance won't be or your displacement won't be negative.
Yeah, good. So I always make sure my directions are the same, so I never forget a negative sign when I actually do my math. What's the next thing we're going to do? Step 2.
Draw a picture.
Draw a picture. Awesome. So we're going to draw a picture. Okay, so we're going to draw a nice vector diagram. Not a vector scale diagram. We're not going to worry about scale. We'll use the eyeball scale. So if something is like twice as long or twice the magnitude of something else, let's try to make the arrow for it twice as big. But don't get your rulers out to actually draw a real scale diagram. So here you can see, right, D1 is 3 times as long as D2. So in our eyeball scale, let's draw that kind of to whatever we think. So here's my starting location. There's a dot. You can put your dot wherever you'd like on your page. D1 goes eastward. So D1 goes eastward. D2 goes westward. And in purple here, that's my total, or I'll put an R for resultant displacement, is like a physics term for it. I call it total displacement. All right, that's how far she's actually away from her house when she finds her phone. Yeah.
Is it wrong to do what you just did just all at once in the first step?
I mean, all at once in the first step.
Instead of writing down, 1,200 meters for D1 or negative 400 meters east, I immediately just realized what the question was asking. I immediately converted it to 1,600 meters and 800 meters.
She did math without showing me math.
That's like so simple though. It's just addition.
People make mistakes. You can do that. I'm not saying you can't do that, but if you get it wrong, you're not getting part marks.
Okay.
So it depends on what you want. My picture's not complete. What's my picture missing? A very important thing. Which goes with what Sloan said earlier, actually. Jake?
Like the distances and directions?
Nope. Their diagrams never have numbers in them. They always just have the variables. That's why we make a table of values so they're not in the same spot. It gets too cluttered. The thing we're missing is a compass. So we have to know which way is positive and which way is negative. Okay, so we're going to use our traditional compass, where that's east, and I'll just say up is north. So I only labeled 2 of the axes, one east-west, one north-south. So I know that east is my positive direction, west is my negative one, which goes back to our table of values there. And that's it. Andre.
So last year in physics, what we did was when we were drawing a map, we would draw like a arrow and just said that it was positive. So you could say like left was positive or right was positive, and you would use your direction to see what's negative and what's positive.
So you do, like, would you do that?
This is like when no, it would just be like a straight line. Like right is positive. you would say, in this equation right here.
Oh, so you just do that?
Yeah.
It'd just be like this.
Like that?
Yeah.
Well, like, we wouldn't write the X, we just,
Oh, you just do an arrow?
an arrow and then positive.
Oh, okay.
And then like,
In grade 12, we can't do that
oh, why not?
because we work in 2 dimensions.
Oh, that's true. That's true.
And actually, what you don't learn in grade 11 is that this is an arbitrary direction. My positive X could be any direction I want it to be, or a positive direction. It could be on an angle if I want it to be.
Okay, so
So it doesn't really matter where you make it.
the arrow is irrelevant now. We have to do the compass.
You gotta have it. Well, you can still do the arrow, but you have to put a direction to it
Okay.
because everything we're doing is going to be direction based, like north. Like this one, not this is as simple as it gets. So in 2 slides, when we have directions like north 15 degrees east, you're going to need a 2-dimensional compass. I get what you're saying though, Maddie.
For like the communication aspect on a text, if we drew the one you did with the north and the east, would you just assume that that's like positive?
Yes. Yeah, because you all only label the ones that you're going to that are the positive, and the opposites would be the negative. Yeah. That's a good question. Okay. So, if we go through the first question here, right, we want to find the average speed. So we're trying to find average speed, which is our change in distance over the change in time. All scalar based, right? So we have our equation as it's written on the formula page. We do our math or show our work here. So we have d1 plus d2 divided by delta t. We have 1,200 meters plus 400 meters divided by 900 seconds. And that works out to be 1.78 meters per second. Ashley?
Wouldn't it be like plus negative 400 meters?
Pardon?
Wouldn't it be plus negative 400 meters?
So displacement and distance are different. So when we're doing distances, there's no negatives in distances because it's just literally how far you went.
Okay.
So it's a great question. So the other way of writing it, which is something you would see maybe more next year, is you could also do it this way. I just don't like doing it because it gets messy. You can do it that way too. And when you do vector notation, those just mean the magnitude of your vector.
Okay.
Yeah, so they're both the same way of writing the same thing. And that's 1.78 meters per second. All right? Patty?
For our answers, is it okay if you just write velocity equals 1.78 meters per second, or do you want us to write it like your answer? Like the total distance equals
Say it again.
velocity. So for our answer, is it okay if we just put velocity equals the velocity instead of your answer on the screen?
You can answer it. I'm trying to figure out what your question is. So you could like not show your work?
No, I got the same answer,
Okay.
but your answer at the brackets, it has the distance to it, like the total distance. Do we need that?
That has it in kilometers per hour and meters per second.
Oh, okay.
Yeah, they're just 2 different ways of doing the same thing.
Oh, but do we not want it in meters per second?
It doesn't say specifically, so I always use meters per second, but I've had students do this on their own before where they keep it in everything in kilometers and meters,
Yeah.
and then so they get both answers.
Okay.
In uniform motion questions, you don't have to go to meters per second because acceleration is not involved. As soon as you bring in acceleration, then you have to go in meters per second. Yeah. All right. For B, I'm gonna get rid of this purple part here, but keep it all on board. B is the average velocity. So B is your average velocity. Same equations with the arrows on top. There are different ways to do this one too. I'm going to keep it like I did before. So for part B, same equation, same setup, but we're using vectors this time. So that's when we have to use the negative. And we get the answer there. Does that make sense? How that works? Hunter?
If you were to like accidentally find speed instead of displacement on a test, how many marks would you lose?
Probably half a mark. Maybe a mark. Depends on what the question's out of. All the questions that you will get, it will mostly do this type of math with 2 dimensions, which is not as straightforward, or projectile motion, in which case you're only dealing with the range. We're trying to find delta x, or delta d.
Okay. So it'd be like multi-step, and this would just be one thing that we need out of everything else.
Are we okay with the answer for C? What's the answer for C? We've kind of answered this question already twice today. Annabella, what would be the answer there, since this is your question?
The last traveling, the leg traveled would be 800 meters west.
Yeah. So if she did 800 meters west to go home, right, then her average velocity would be a number, but her average speed would be a number, but her average velocity would be 0 because she's back to where she started from. Make sense? Any questions with this one and how we set it up? Solved it. I didn't do a therefore statement. You do one therefore statement to tie together both A and B on a test. And in your notes there you can do that too, right? Just say that her average speed was that and her average velocity is the other number. So that'd be a level 4 answer, right? Show all your work. Okay, the next one's harder. That's the softball question today. Here is a harder one. It's me. It is yours. Okay, take a moment, read it, draw a picture. So these are questions you're going to see that don't have a specific route to the answer. There are different ways to answer this question. Right? You have tools in your toolbox. You have to figure out how those tools go together to get where you need to be. Alright, so this is a calculation your brain does quickly as you decide to hit the accelerator or hit the brake. So take a moment. I'm gonna let you think about it because I'm gonna ask you how you want to solve this question. So there are different ways to solve this question.
kilometers per second converted to meters. 0.9 kilometers. That actually, no, it's going to be 60. It's 60. 50 meters per second. That's what should
Well, I think that the first displacement would be when the light turns red, and I think we should try and solve for the second displacement to see where he ends up with that acceleration.
Okay, and then what will we do when we have that number?
Well, if it's over the 400 meters, then we know that he didn't stop before the intersection.
Awesome. So Maddie's idea is to solve for the displacement. So how far does Ethan actually go while he's braking? And then compare it to the 400 meters to see if he stopped before or after the red light. Did anybody choose a different method? Sloan?
I was going to do it where like the final velocity is 0 and I'll have to find the distance. So I'll figure out if he was able to brake because the light's 400 meters. So if his distance while braking is far greater, then he didn't stop.
Yeah.
And if it's less, he is able to.
Okay. Yep. Okay. Anybody else have any other suggestions? Another way to do it, which nobody mentioned, is that you could find his speed given the acceleration, the distance, and the initial speed, right? Find the final speed at 400 meters, right? And if he still has a speed, then obviously he's still moving forward through the intersection. And if he doesn't, which he would not in this case, because we know the answer is yes, he does stop. You'd actually have to get the square root of a negative number, and that's not a possible solution, so you know that he would be stopped. So think about that, because I see you guys are all putting pens on paper, rushing through this, right? There is a way sometimes where the square root of a negative number is an answer, right? You have to put it in context of a question. You can't just say, oh, well, it doesn't work out, I screwed up. Well, you did everything right, and that you have to interpret what that means. So we're gonna go, it sounds like everybody's kind of doing the same thing. We're gonna find the displacement and then just compare it to 400 meters to make sure everything kind of works out. Okay? So we do this together. We're gonna start with our table of values, right? So what goes in our table of values here? Ethan, let's go with you. This is your question.
Which way are we solving? I guess, I mean, it doesn't matter.
Doesn't matter.
Yeah.
What are our values?
We have an acceleration of 0.3 meters per second squared south or negative 0.3 meters per second squared north, if that's how we want to write it.
Your question, how do you want to write it?
Negative.
Okay.
There's, a distance of 400 meters, I guess, or a displacement of 400 meters in this case.
Okay.
Is the 54 kilometers an hour, are we using that as an initial velocity in this? Yes, because it could decelerate. Yes, so initial velocity of 54 kilometers per hour, which is, I turned it to 15 meters per second.
Exactly 15 or 51?
I think it's exactly 15.
Okay.
I didn't get meters.
Yep.
So that's and then we're
You're missing one.
one that we know or don't know.
One that's implied, inferred, if you will. Okay.
The velocity final is 0 meters per second.
Yep. So we're gonna stop. Okay, so we're going through the route where we're trying to compare to the 400 meters. That's actually not one of the variables in our question, right? You have too much information. So you have to make sure you kind of sort through. So our diagram, right? We have our roadway. We have Ethan in his car. To the car? Doesn't say. So here is Ethan's car. Minivan. It's going northward at a velocity like that, has acceleration going backward. We have a displacement to the car. Right, so we have a little diagram, right? It's really important that you take the time to interpret the question in the diagram because it helps slow your brain down to help you think through the problem. And if you can't draw it in a picture, that means you don't understand the problem. So take your time. All right, so we have our Ethan in his minivan. Where's my pointer? Here we go. Right, we have our initial velocity going north, our acceleration is going south. Our displacement, which is delta D1, also going north, measured from the same spot of the car, beginning to net. And our VF is 0. Okay, so everything's there in a diagram. Take a moment, doesn't have to be pretty. I can't draw very well, so that's as good as I get. So take your time to interpret the question, because you're going to get these where they're yes or no answers, and you have to use your math to back up your opinion. What equation are we going to use here from our list of 5? If we go in the order we wrote them down today, what number are we going to choose? Ashley? Number 1. Right. Right. We have the initial speed, final speed. We want to find displacement, and we have the acceleration. Vf squared equals Vi squared plus 2a delta D. We want to find delta D, which I call delta D1. That's going to be Vf squared minus Vi squared divided by 2a. All right, and we can throw our numbers in there. We have 0 meters per second squared minus 15 meters per second squared divided by 2 times 0.3 meters per second squared. And what does that work out to be? It's like 350 something, if I remember. Is that right? Oh.
375.
375.
Is this obviously that doesn't that literally doesn't work?
So when you're talking about level 4 plus communication, your therefore statement is really important in this question. Because if you said therefore the displacement is 375 meters north, that doesn't answer the question. Right? My question is, does he stop in time? Right? So a 4 plus communication would be along the lines that yes, Ethan stops in time. He stops 25 meters before he gets to the light. Right? Making sure you use your answer to support your therefore statement. That's the key. Right? It's like your test that you wrote when I asked you the color of light. Right? A lot of you picked colors that weren't the right ones, but you didn't justify your choice. If you chose yellow, why did you choose yellow? Right? And you had to base it off the answer that you get to support your answer, right? So same thing here. Yes, he does stop. If you write down, therefore, yes, he stops, that's great. I won't give you level 4 communication for that. Right? You got to tie in your answer. Alan?
Can you do the example by using a different method?
Yes, for sure.
I didn't solve it that way. I instead just did the different equation, which is VF squared equals VI squared plus 2A delta D.
Which is the same one there, yeah?
Wait. How did you...
What did you find though?
Oh, I was essentially solving if D was equal to 400 meters.
So you put D equals 400 meters?
Yeah, and that would determine if VF was 0 or lower.
If you did that, then you would get the square root of a negative number, right?
Yeah.
Yeah.
And then since it doesn't, you can't equate a negative number.
Then it doesn't go that far. Yep. All right, are we good? You guys want to have our break? Okay. So the only other thing we have to accomplish today is we're going to look at a two-dimensional question that deals with displacement.